The model also showed cooler sea surface temperatures creeping into the higher latitudes of the North Pacific by around year 5, becoming well established by year 20. That North Pacific cooling would eventually cause sea ice to expand in the ocean basin, which would reinforce the cooling as a result of the extra sea ice reflecting the sun's energy back into space via what's known as the albedo effect. By about year 30, the model showed that cooling would start happening in the equatorial Pacific, evolving that region into more permanent La Nina-like conditions. We took a closer look at the effects of a sustained La Nina quite recently. Suffice to say, they're not great, especially for countries like Australia and Africa. Then there's the shutdown of a crucial movement of heat from the southern hemisphere to the northern hemisphere via the great thermohaline circulation that I mentioned earlier. With that switched off, most of the ocean heat stays down south, with the biggest contrast between southern and northern ocean temperatures occurring after about 3 decades. To compensate for the lack of oceanic heat transport, nature turns to the atmosphere in an attempt to balance global temperatures. There's a strengthening of something called Hadley cells in the northern hemisphere, which are pockets of warm air that rise at the equator and move towards the poles. Hadley cells also create the trade winds, tropical rain belts, hurricanes, and the jet stream. So as they get stronger, all those events become more extreme as well. The study even demonstrated AMOC connections to atmospheric circulation over the West Antarctic, with indications that the greater retention of ocean heat in the region would bring about an accelerated melting of the ice sheet, with all the catastrophic consequences of sea level rise that I'm sure we're all aware of. Now, there's a big caveat here, and that's that the research team concede that these results were derived from only a single computer model that was set up under pre-industrial conditions. They suggest future work should examine the impacts of an AMOC shutdown under a range of scenarios that take into account increasing atmospheric greenhouse gas concentrations. So once again, we find that the accuracy of climatic predictions are only as good as the models we base them on, which means there's still a lot of variation in the detail.